Hi, this is Mr. Hanna. Welcome to what format. This is a video on solving systems of equations using elimination, or you'll see down in parentheses addition method. Why two names? It's a good question. When I was a student, it was the elimination method. The idea is we're going to use math here to get rid of one of these variables. We're going to eliminate it. How are we going to do that? Well, we're going to add these two equations together. So some bright soul realized, hey, I can call it the addition method now, not just elimination. Now I create a new word, I can reprint my textbook or material, I'm reinventing the wheel, but hey, that's what they do a lot in math these days. Why? Well, that's I guess a question for another time, but all it really does is make it more confusing for students because now instead of remembering one name, you gotta remember two. And you don't, who knows what your teacher will use. I know teachers that still call elimination method. Why? Because that's the way it was for so many years. Others are now adopting the addition method. It's no different, but that's why English is one of the hardest languages to learn. So many different words, and sometimes a lot of the words mean the same thing. Big, large, huge, giant, vast, gargantuan, humongous. I mean, go on, you could probably think of some more there, right? They all kind of mean the same thing. Of course, there's different context for them, but essentially they mean the same thing. And people get confused by that. Well, when do I use which one? That can be confusing. They've started to get that way with math. Words mean something in math. That's supposed to be, and to me, the fewer ways to say it, the better, because there's less confusion. But in this case, we got two things. So hopefully you can get through that. What's the idea? We have to eliminate the variable. So what are we supposed to do to eliminate? Well, let's take a look. What's negative 4 plus 4? 0. Opposites cancel. That's what we want. We want opposites, because when we add opposites, we get 0. And if I put an x here or a y, it doesn't matter. 0x is, 0x here is what? 0. See, the variable's gone. It's eliminated because when you add 0 to something, that just basically went away. And I know what you're looking at. So, well, Mr. Hanna, we can't do that. 3 and 2 aren't opposites. Either 3 and negative 1. Haha. But we can make them opposites. Well, how would we do that, Mr. Hanna? Well, let's take a look. If I want 3 and 2 to be opposites, I'm thinking 6. Yes? Because 3 and 2 have 6 in common. Think of it like a common denominator situation. So if I want this to be 6, I'm going to multiply this equation by 2. Okay? If I want this to be 2, I'm going to multiply by 3. But now we see an interesting issue here. 2 times 3 is 6, 3 times 2 is 6. 6 and 6 don't cancel. So one of these has to be a negative. Which one? Well, it doesn't matter. Take your pick. If you make this negative 6 plus 6 will cancel. If you make this negative 6 plus 6 will cancel. I'm going to go with this being negative. So then what do? Well, we actually distribute. And yes, you can actually distribute across an equal sign. But be very careful. You miss one part of this distribution, the whole thing breaks down. And that's what gets me with these. I will make a lot of mistakes there sometimes. I have to be very careful. Okay? Negative 2 times 3, negative 6x. Negative 2 times 3, negative 6y equals negative 2 times 6, negative 12. Make sure you finish that. Watch your signs. 3 times 2, there's your 6x. Well, good. I can already see they're going to cancel. I like to sometimes do that right away because it gets it out of the way. 3 times negative 1, negative 3y. 3 times 7 is what? Well, that's going to be 21. Yes? Now, negative 9y equals 21 minus 12. Ooh, see? Easy to make mistakes. I started to put negative 9 there. My brain got influenced. It's just 9. Those are things to watch for. Even I make mistakes sometimes. I've been doing this a long time, but I have never found a way to be 100% all the time. That's why I'm careful. That's why I go through a system. It makes it easier for me to catch my mistakes because my brain knows what it's doing. I can stop and check. 21 minus 12 is 9. If you need to do the math out to the side here, go right ahead. Plus 21, that's minus 12, so you're subtracting, borrow. 11 minus 2 is 9. 1 minus 1 is 0. There's your 9. If you have to do that, please do so. Now we're going to divide by negative 9, and there you go. Y equals 9 over negative 9. Positive over negative is negative. 9 over 9 is negative 1. And you'll recognize these equations if you've watched my last two videos. If you haven't watched my last two videos, then this wouldn't have meant anything to you, but this was the answer we got from the last two videos. You'll notice we still got y equals negative 1. So this was my way of checking that this method still works. I'm using the same equations with the 3 different methods. If I get the same answer each time, I know I'm doing it right. So there you go. Now what do? Well, you got two equations up here. You can plug negative 1 into here or negative 1 into here. I'm thinking probably the smaller numbers. That's usually the way I think. But, let's just plug in the 3x plus 3y equals 6. So now I got 3x plus 3 times negative 1 equals 6. Yeah? So then that's 3x minus 3 equals 6, because 3 times negative 1 is minus 3. I'm going to add the 3 over. I'm going to get 3x equals 9. Divide by 3, divide by 3. There's x equals 3. So there's my 3, negative 1. Just like I was supposed to get. So elimination works. Wait, Mr. Anna, are you sure it works when I do the y? Let's go ahead and do that. Because in this case, eliminating the y was actually the easier way to go. I did the x first because I wanted to emphasize and show you the most math you'll have to do is you'll have to multiply one equation by one number or the other by another number. And sometimes one of those numbers will have to be a negative. Okay? This would have been the easiest because that's already 3. All I need to do is make this a negative 3, so I can just do that by multiplying by 3. That was one multiplication. So I did it a more complicated way, A, to show you all the steps, and B, to show you that it works either way. And that it really isn't that bad when you just have to distribute twice. But a lot of students, the more math it is, sometimes they freeze up. But hopefully this showed you that it's not as bad as it looks. Take it a step at a time. And notice again, we're using a lot of stuff over again. Once you get this eliminated, you're just solving for y. And then once you plug it in, then you're just solving for x. Just stuff that you should be familiar with, but of course, like I said, if this is something you struggle with, especially the integer math, it doesn't go away. It's going to keep coming back. And if that's what you're missing, then it's not the concept you don't understand, it's the math with the concept or your math skills. Good time to go back and try to strengthen those. Fix where the holes are so you can move forward. If you don't fix those holes, moving forward becomes a nightmare. And I know a lot of students who just, they're having problems even for various reasons, Maybe it was your COVID years. Missed some things that you should have gotten and you just never been able to catch up. Maybe it's just you were sick one year, missed a lot of school. Maybe it was you had a long-term sub because you're, for something wrong with your teacher had to leave or something, or maybe you just didn't get along with the teacher and you didn't like the way they taught. Any various reasons. There's lots of reasons students have holes in math. The thing is those holes need to be fixed, otherwise you're going to struggle with math the rest of your life. So, just a reality check, which unfortunately is life. Sometimes life just doesn't care what happened to you. They just expect you to fix it. So if you're having trouble with integer math, maybe go practice that. I do have some videos on sign math, so you could watch the video on that to try to get that fixed. And those signs that works for integers, works for fractions, works for decimals. And those are things you need to be able to do, that 5th grade math. You need to be able to add, subtract, multiply, divide any number in any format. It doesn't matter how big or small. So we need this to be 3, so I only have to multiply this by 3. So that's going to be 6x minus 3y equals 21. 3 times 2 is 6x, 3 times negative 1 is negative 3, 3 times 7 is 21. I like to double check that. You miss one of those, which is easy to do. You already saw me start to make a mistake last time. That one mistake is all it takes to mess the whole thing up. I would have gotten y equals 1 instead of negative 1. Big difference. Okay, I like to bring this down. But make sure you copy it exactly. Sometimes this is one area where I have trouble. The more I write these, there's times I drop numbers. That 3 becomes a negative 3 for some reason. Why? Well, maybe I look at this before I write it. My brain is thinking negative. Our brains are very visual. They will do that. So just be careful with your steps. So 3x, 3x, 3y, 3y, 6, 6. Now I'm going to add these again. That's why they call it the addition method. But we're eliminating y. Therefore, also why they call it the elimination method. These should cancel. I like to just cancel them. 6x plus 3x. I'll even bring it over here. Why? Because it's right next to my number, which is now 21 plus 6, which is 27. I can now divide by 9, and you'll notice I'm going to get x equals 3. So in this way, I'm working backwards. Last time I solved for y first, got negative 1. Plugged it into my equation, got my x. Now I get the x is 3, so we'll plug it in. Which one? Well, again, maybe just plug it into there. 3 times x, right? So that's going to be 3 times now 3 plus 3y equals what? 6. So 9 plus 3y equals 6. I'm going to subtract our 9, 3y equals negative 3. We're going to divide by our 3, get y equals negative 1. And there we go. There we are. So I did this both ways with elimination to show you it doesn't matter which variable you decide to eliminate. And that's very important because I have had Seen lots of students over the years get confused. There's more than one way to do it, and they get confused and sit there between two choices. And I say, what's stopping you? They go, well, I don't know what to do. Get the X or Y out first. And I tell them it doesn't matter. And they're like, oh, it doesn't? So now they sat there and confused themselves and made the problem really big just because they got stuck at a choice that really didn't affect their answer. So it's really good to know which way you can do it. In this case, you've got either variable you can eliminate, X or Y. Now all of a sudden, wait, I can do substitution, I can do graphing, okay? Now of course, again, elimination is the way that works all the time, 100%. Substitution has some limitations, so does graphing, mainly based on the way the equations are given. And the people that write tests, they know that, so sometimes they'll still steer you in a certain direction. That's why I like to know the way that works all the time. That way when I'm in a test, instead of freaking out about, well, do I graph, substitute, or eliminate, then I'm like, okay, I'm in a test, I know elimination works, I'm just going to do it that way. Multiple choice, standardized test, define the answer, they're not going to grade your work. You want to have that go-to solution. This is it. That's one reason I took a little extra time to make sure you can see that it doesn't matter which variable you use. With Mr. Anderson, what if I plug that in the other equation? Okay, let's do that. Let's plug 3 into there. What do we have? We have 2 times 3 minus y equals 7. So 6 minus y equals 7. We're going to subtract the 6, negative y equals 1, divide by negative 1, divide by negative 1, y equals negative 1. See, same answer. Doesn't matter which equation you pick, doesn't matter which variable you eliminate. Well, Mr. Hanna, you didn't do that last one. Okay, let's do it mentally this time. We didn't get the x, we got this was negative 1, right? Negative 1 is plus 1. When you subtract 1, you get 6. What's 6 divided by 2? 3. There you go. Doesn't matter. Okay, some things in life, it just doesn't matter which way you do them. You just have to pick a way and go. There are sometimes more than one way. The old saying when I was a kid, maybe not popular these days, but is that more than one way to skin a cat. Okay, more than one way to do something, more than one way to drive somewhere. Which way? Well, sometimes there's a personal choice. Maybe some people like going this way. Maybe they like the scenic route better. Yeah, okay, it's a little longer, but they still get there. They enjoy the ride. Others like the short, quick route. Others may not like the traffic in a certain direction. Maybe others don't mind it because they like listening to the radio, taking a little longer, sitting in the car, relaxing. More than one way to do things. Find your way and do it. Find your way and do it. Practice it until it gets easier and easier and easier. If somebody shows you a way it works and you like it, copy it. If it doesn't quite work, tweak it. Okay? Hopefully you see these videos aren't just about solving these problems. It's about teaching you how to think. Now, hopefully they're helping you with your math class. Your math grades improve. You gain confidence. You realize, hey, I can do this. Solving math problems. I like solving math problems because they're the closest thing to solving life problems that I've seen. Solving math problems, it's in science and it's lots of different applications of things as you grow older. It's in coding. It's in all sorts of stuff. Math is everywhere. It's a universal language. So if you can get good at math, you can hopefully get confidence that you can solve any problem that you come across as you go through your life. And that's what really this is about. Learning how to solve problems, learning how to think. Not just having to have stuff give to you. You learn how to analyze and think through things. Because there's a lot of information coming your way these days. And it's be a wise thing for you to be able to think for yourself and not just have to do what you're told and believe everything that you're told. Because at some point somebody's going to lie to you because they want you to do something their way or a way that benefits them and actually will end up harming you. And unfortunately there are people out there that just don't care about that. So learning to think for yourself is very, very, very important. This is how we practice. Okay, more than one way to do things. Find the way that's comfortable for you. Practice it. Think for yourself. Trust yourself. Anyway, this has been Solving Systems of Equations, Elimination or Addition Method. Hopefully with 3 videos you have the 3 methods down now. And thank you for watching What the Format. This is Mr. Hanna. Happy math.